Okay, in this video we're going to talk about variance and standard deviation. This is something you should have covered already. Standard deviation is basically the square root of variance, right? So they're basically kind of telling you the same thing. It's just, variance, this is variance, and standard deviation is if you take the square root of that, right? So what standard deviation tells us is it tells us on average how far is each point from the mean, right? So basically what you would do to find standard deviation of a normal data set, right? Let's pretend we had this data set, then the mean, the population mean, would be 3, right? It's you add all these up and divide by 5, you get 3. The standard deviation would basically be taking that mean and subtracting it each number from, or that each number minus the mean, right? And then squaring it. The reason we square it is to get rid of the negative. It's easier than doing absolute value. So I'm just giving you a brief overview of what standard deviation is, right? And then once we do that, we end up dividing all of this by 5, because there's 5 things in here. So we're finding on average how far is each one away from the mean. And what that gives me is standard deviation, right? Because I squared them all. If I square root that whole thing, then I end up with the standard deviation. And so in general, how you do this is you take each xi, right? This would be x1, x2, x3, and you subtract the population mean, and you add all these together, you square it, you add them all together, and you divide by n, the number of things that there are. And then that would give you the standard deviation, and that would give you the variance, and if you took the square root of that, you end up with the standard deviation. Right, so we're going to apply that same thing to our probability distribution, our discrete probability distribution. We've already seen that the mean is the same as the expected outcome, right? On average, you expect, the mean thing to happen. We figured out that can be determined by taking each outcome that we want and multiplying it by the probability of that outcome. So applying what we just talked about over here with standard deviation, we could then do that same thing if we're doing 10 trials. You can see this is just each individual term subtracted from the mean squared divided by n. That's the same formula that we just talked about here, right? The only difference is we're going to multiply by frequency because how many times does it happen. But then notice how if we do this specific example, right, the frequency is 1, 4, 3, 2, right, which is, these guys. What happens is that you notice that these just become, when you divide by n, these just become the same thing as those probabilities of those things happening. And so you could have just written this whole thing and not worried about the frequency, but only considered the probability, right? And so then we learn that variance is the same thing as, like, our formula for variance is this here, right? Each individual one minus the population mean squared times the probability of each one happening, right? And this just goes through that in general. And again, you end up at basically the same result, but it's just giving you in general for each specific piece, right? And so that's where we get to this, just a brief summary of what we talked about. The expected value is the same thing as the mean, and it's given by adding up, the possible value times the probability of that value, multiply the product of those. The population variance is this formula here, adding up each number minus this expected value, right, which simplifies to this, and the standard deviation is taking the square root of the variance, right? So let's look at an example. We want to find the standard deviation for this. So what do we need to do? Well, first we would need to know what is the mean, right? And the mean, the expected value, which is the same thing as mu, which is the population mean, would be figuring out, 1 times 0.23 plus 2 times 0.38 plus blah, 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 until you get to 5 times 0.05. We actually already did this in a previous video, and we got 2.39, right, which this was the magazine one, right? So what we said was on average we'd expect any random person to come in to purchase about 2.39 magazines, right? Again, you can't purchase 0.39 magazines, but it just means like more people would purchase 2 than they would purchase 3, because it's closer to 2 than 3. If we want the population, let's start with variance, and then we're going to sum up each individual one. So we're going to do basically, I'll just write down the formula: xi minus mu squared times the probability, and we're going to go from 1 to 5 because we go from 1 to 5 here. So what that would look like, again, this is really easy to do with a calculator, but what that would look like is if I plug in 1, then x1 is 1 minus 2.39, we square that, times 0.23, right? And then you'd add that to the second term. The second x2 is 2 minus 2.39 squared times 0.38, and hopefully you get the point. You do the same thing until you end up with 5 minus 2.39 squared times 0.05, and then that would give you your variance, right? So let me just see what that gives us real quick. Again, if you did this, you would end up with about 1.258, right? And again, this is our variance, which is the standard deviation squared. And so to find the standard deviation, which is what this is asking for, find the standard deviation, we just have to take the square root of this, right? Again, if you just do this on your calculator, you'll get 1.258, and if you take the square root, you get 1.122. And this is our standard deviation, right? Remember, standard deviation is basically telling you on average how far is each data point from the mean, right? So on average, each person is about 1.12 away from the mean. There's also, if you've ever learned this, some really cool things like with normal distribution. If it's normally distributed, then the mean would be here. And if you go out one standard deviation, meaning if I add 1.122 here, which would put me at 3.51, and subtract it here, which would put me at 1.27 about. We know that about 68% of my data, 68% of customers would buy between 1.27 magazines and 3.57 magazines. And we could go out another standard deviation, 2 standard deviations, and 95% of people would be there. And if I go out 3 standard deviations, you get 99.7%. I don't know if you've learned that. We will be hitting on that in a little bit later. And the purpose of us doing this again is to make sure we understand these formulas. And so you should now better understand this formula down here, right? If I want the variance of a random variable, it's just your x minus your mean squared times the probability of each xi, right? So this is, x1 minus the mean times the probability of x1, which then you could simplify to this formula here, which is, again, if you, I don't know if I can write on this, but if you were doing this, just recognize that this is the notation we've been using for this piece here is just p sub I, right? That's all this is p sub I. So you do whatever squared times p sub I minus the mean squared. So hopefully you better understand these. What you should do now is you should be practicing 25D, these problems. And I'm going to go over some properties as well, and then we'll do some practices on that too. Okay, so we're going to look at some properties of the expected value function that will then help us rewrite some formulas that make life easier. So there's 3 on here. The first one says the expected value of k, which k is a constant, is just k. So what you might want to think about is maybe you have like a coin that has the number 2 on the front, and on the back it also has the number 2, right? So like think about what are the probability, in this case x, the sample space is 2, right? And what's the probability that I get a 2? Well, 1, right? So what's the expected value of this thing? What's the expected value of this function? Well, 2. Like every single time you do it, you'd expect to get a 2 because that's the number on there, right? So that's kind of obvious case, but it's there. The other one is if you have the expected value and you have a constant times your variable, you can bring that constant to the outside as long as it's a constant, right? And then the one that really throws me off sometimes is this. If you have the expected value of the sum of 2 probability distributions, that's the same as the expected value of the individual ones and then added, right? So you can either add the distributions and then find the expected value, or you can find the expected value of each and then add, right? So an example of what this allows us to do is, again, the first two are kind of obvious, but this third one is, let's say I had the expected value and my probability distribution looked like this. Then I could separate this into three pieces. I could just do the expected value of x squared plus 2 times the expected value of x plus 3, right? And that's just using this property directly, as well as the second property. Maybe in between you write, maybe there's this in between step, right? So like that would be separating each individual term. And this one goes there. This one you can use property 2 to factor the 2 to the outside, and this one is just using property 1 to say the expected value of a constant function is just that constant, right? So there's properties of variance, which look like this. Basically, what you have to remember is that e to the x is the same thing as the population mean, right? So when you see here e to the x squared, that's e to the x squared would just be the same thing as the mean squared, right? So that's how you get to this point here. And there's a proof for you there. Again, examples are usually the easiest, the best way to go about this. So if you want the mean of x, here we have our xi and our probabilities for each one. The mean, remember, is the same as the expected value, which is the same as mu, which is the sum of xi times the probability of that. So in this case, for A, you would just have 1 times 0.1 plus 2 times 0.3 plus 3 times 0.4 plus 4 times 0.2, right? You multiply all those out. And that is, darn it, hold on, 2.7, right? So if in this case, we expect 2.7 to come out the most, right? For whatever this is. Maybe it's spinning a spinner of some sort. For B, we're looking for the variance of x. So we're going to go up here, and we're going to say, okay, another way to think about variance of x is here. The expected value of x squared minus the mean squared, right? So let's start with what is the expected value of x squared. Well, that's the same thing as sum of the xp squared times pi, right? It's the x is being squared. So basically you just go through and you do the same calculation as above, except you would be squaring all the x values, right? So this is an easier way to calculate the variance than what we did before, right? And so you'd end up squaring all of these pieces, and you end up with 8.1. So that's the expected value squared. And again, we're doing that because we're trying to find the variance using this model, right? An easier way to do it. If you look at the formula book, it also has this in there, right? The variance for standard deviation is here, right? You can do it this way, just basically what we're doing. We're calling this the mean squared because we know that that's the mean squared. So just showing how to use that formula there. And that's 8.1. And so then the variance is going to be that number minus the mean squared, right? So my variance is going to be this number, 8.1, minus my mean squared. My mean was 2.7. And so our variance is going to be 0.81. Right, that's our variance. And if you want the standard deviation, you just take the square root of the variance. The square root of 0.81 is 0.9. And so our standard deviation is 0.9 in this case. Okay, there's another example in the book that just goes over some properties of finding this. So you can read example 10 and maybe figure out for yourself. If not, just reach out to me. I'll make a video about it. But then you should be trying these problems from exercise 25E. And the next video we'll be going over the binomial distribution and Poisson distribution.